Hello everyone, today we are going to discuss about few topics of real numbers in class 10th. So the first topic is fundamental theorem of arithmetic. What does it say? What does this theorem say? Fundamental theorem of arithmetic says that any composite number can be represented as the product of prime numbers. For an example, first of all, let me explain you what is a composite number. The composite number which has more than two factors other than one, which has two or more than two factors other than one, that is called a composite number. Like if we talk about 2, what is its factor? Its factor is 2 itself other than 1. 3, 4, 2 into 2. It's a composite number. Okay? Why? Because it has two factors other than 1. And if you talk about 10, it is 2 into 5, composite. And if we talk about 20, it has 2 into 5. Yes, composite numbers, right? And these are primes, correct? So that's what a composite number mean. So the theorem says a composite number can be represented as the product of prime numbers. Here is a composite number. It can be represented as product of primes 2, 2, 5. So 2 and 5 are prime numbers. So here's our theorem proved. Now we'll discuss about the very familiar topic to you, LCM and HCF. Okay, what are the LCM and HCF and prime factorization? And I'll show you the prime factorization using factor tree that you already studied before. So let me take, okay, I'll take 240 itself. Okay. How to represent it in the factor tree? 240, right? If the first factor would be 2, here dividing 240 by 2, 120, 2, 60, 2, 15, 3, 5. That's it. Okay, that's a factor tree and that's its prime factorization. Alright. So when we talk about LCM and HCF, the first thing we have to do is the prime factorization of any number. Correct? And LCM and HCF, to find LCM and HCF we need at least two numbers. So let me take for an example two numbers. Be 6 and 20. Alright? We have two numbers 6 and 20. We need to find out the LCM and HCF for. So first of all, we'll talk about HCF. Okay. For that, we need the prime factorization of 6, which is 2 into 3 and 20, which is 2 into 5. Right? Now, how to find the HCF? What method do you use? You check first of all what are the common factors. Okay. Any more common factor in both of their prime factors? No? So that's it. The HCF is 2. Okay. What about LCM? How to find the LCM with this prime factorization itself? Okay. You can use your traditional method also, like 6 and 20, the same. 2, 3, 10, 2, 3, 5, 3, 1, 5, 5, 1, 1. So LCM equals to 2, 2, 3, 5. 2 into 2 into 3 into 5. That is 60. That's how you can find out. Or if you want to use this one, what you have to do is 6 equals to, you got 2 into 3, and 20 equals to, you got 2 into 2 into 5. Right? So how to calculate? HCF, what HCF you got? You got 2 as HCF. So out of the prime factors of all these two numbers 6 and 20, what are the prime factors? 2, 3, 2, 2, 5. You just remove 1, 2. Okay, just remove it. It's gone. Now whatever remaining will give you the LCM. 2 into 2 into 3 into 5. 2 into 2 into 3 into 5. Like this, right? So here by using this method we got a relation. What? That if I multiply this 2 into that, okay, if I multiply this 2 into that, what will I get? The multiplication of 6 and 20. It means what? This 2 is HCF and that is what? LCM. If you multiplying HCF and LCM of any two numbers, what you are getting? The multiplication of the number. So here we got a relation between the LCM and HCF of two numbers. What is it? LCM of two numbers A and B into HCF of two numbers A and B gives you the product of the two numbers, right? LCM of A and B multiplied by HCF of A and B gives you the product of A and B itself, right? That is the relation you can use in particular problems. Like if you have been given two numbers and their HCF and you have been asked to find out the LCM, directly using this relation you can find out directly the LCM. If LCM is missing, if you have been asked the HCF, you can find out HCF. If any of the number, if these two things are given and any of these two number is missing, you can find out that also, okay, by using this relation. That is about LCM and HCF. In NCERT, there is a problem like state whether 6 to the power n will end with 0 or not. Okay, so any number with having power, any power will end with the digit 0. How to find out? To find out 0, we must see what are the prime factors which gives you 0 as the product. So 2 and 5 gives you 0 at the end. 2 to the power 2 still give you 20. In that case, it gives you 100, like this. Okay, so to end with the digit 0, you must have 2 and 5 as the factor of that number. Here what do we have? 6 to the power n. What are the factors of 6? 2 into 3. Here we do not have 5, right? So if it does not have 5, it cannot end with digit 0, right? To end with digit 0, it must have 2 and 5 as its prime factors. Now let's discuss the word problems based on LCM and HCF. Okay, it's quite difficult to find out what we have to calculate in word problems. Either it is LCM or HCF. It's not easy to judge which kind of problem it is. So we have few key terms. Okay, if these key terms are available in this word problem, you can easily find out what we are going to find out, LCM or HCF. Okay, I'll give you a few key terms. First of all for LCM, then for HCF. Okay, so the first key terms, if there is any word mentioned like cycle or circular, like this kind of circular path, okay, they are running in a cycle, or if this any kind of this key terms is there, then you have to go for LCM. Another, if anything is happen again same time, okay, or if someone is if few people are running on a circular path, if they meet again on same time or same place, okay, that kind of problems, that is the first one. Second one, so these few are key terms by which you can identify whether the problem is of LCM or HCF. One more, if there is mentioned that anything you need to find out is least, okay, or smallest, or minimum. Okay, if first of all you have to go for these two key terms. If these two are not available, then you can go for this least, smallest or minimum. If they are there, then you need to go for LCM. Alright, then let's talk about HCF now. Okay, the first thing what will be mentioned in for HCF is like you are making any group of something, or you are staking something, making stakes of any goods. So this will help you grouping or stacking. Okay. Second, if you are dividing any group of students equally, or you are like splitting them equally and nothing is left, so divide or split. That's not divide or dividing a number by something, nothing. No, dividing means dividing any particular group of something into 2 or 3 parts, kind of this, or splitting them. If you are sharing something, okay, sharing and no leftover, nothing is remaining after that. Okay, that key terms are also favorable. Right. The last comes, if here is least, smallest, minimum, there would be highest, greatest, or maximum. Okay, so these key terms will help you to solve any word problems and to identify which kind of word problems are there. In this also, first you have to go for these 3, at the last comes 4. Now, why I said these 2 you have to check at the last, because there are few problems like find a greatest number of 6 digit, which is when divided by any 3 numbers leaves a remainder 5. Okay, so find the highest or greatest 6 digit number, or find a minimum 2 digit number or 3 digit number. In that case, what happens? This factor doesn't matter. Okay, least, highest, it is not for them. Okay, it is for word problems when you have been given a real life situation. Okay, in that case only you have to apply these key terms. Understood? So, which problems I have just discussed with you now, like find the 6 digit number, find the greatest 6 digit number. So, greatest and smallest 6 digit number which has 6 digits. So, greatest number would be, we consider always the greatest number like this. So, that is the greatest number of 6 digits. And what is the smallest number of 6 digits? That is greatest, and that is smallest, right? That's how we consider. If it is 6 digits, 6. If it is 5 digits, 5. If it is 4, 4, like this. Okay? So these are greatest, smallest. It doesn't have anything to do with those key terms I just showed you now. So greatest, smallest, if it is mentioned, that is only for this key terms, or find any greatest number which divides this or any particular number. So that doesn't have to do anything with those key terms. Like for an example, if you have been asked find the greatest number which divides 240, okay, leaving a remainder 5. 240 and 60. Find the greatest number which divides 240 and 60, leaving remainder 5. Okay, so if there is mentioned greatest, so no need to use the key terms. You have to understand there are 2 kinds of problems here we have. What? First, when 2 numbers are divided by something, when 2 numbers are dividing something. Okay, you must understand it. When any number is dividing these 2, if these 2 numbers are divided, then these 2 are dividend, and the divisor must be smaller than them, right? It cannot be greater than them. Then if they are divided by something, then what could it be? What could it be? The smaller number. Okay, it should be smaller than, it should be smaller than these 2. If it is dividing these two, then the number must be smaller than these two. Now here we have two things, LCM and HCF. Now tell me which of these is smaller than the given numbers. We find the LCM of these two and HCF of these two. What will be the smaller one? That is the smaller. Okay, this one is smaller and this one is greater than them. Okay, so when any two numbers are divided by something, it is always their HCF. Okay, and when any two number divides okay, any number, if these two are dividing anything, it must be greater than them, so it would be LCM in that case. Okay, it must be greater than. Okay, so now understood. We have discussed two kind of problems. First, real life situation word problems, and these two kinds of word problems. So be careful about that. Now we will see how to prove any irrational number irrational. Like for an example, what are irrational numbers? Root 2, root 3, 4 root 5, kind of this. Okay, these are called the irrational numbers. How to prove them? There is a particular method you need to follow step by step, so you will be able to solve any kind of these problems. So like let me take one example. Prove root 2 is an irrational number. Now you see it very carefully. Okay, so proof. How to prove? First of all, we'll start by we'll use our contradiction method. Okay, what is contradiction method? Is, you remember, what we have to prove is we just take opposite of it and we prove ourselves wrong. So we have to prove root 2 is an irrational number. So what we'll let root 2 is a rational number. Let root 2 is a rational number. Okay, if it is a rational number can be represented as P upon Q or A upon B, right? So root 2 can be represented as A upon B, where A and B are any integers and they are co-primes. Co-primes. What is co-prime? Co-prime, if two numbers are co-prime, it means they doesn't share any common factor, like 2 and 3. What is the factor of 2? 2 itself. What is factor of 3? 3 itself. They do not have any common factor. We are not talking about 1. 1 is common in all. Okay, so other than 1, do they have any common factor? No, so they are co-prime. 2 and 4, do they have any common factor? Yes, 2. It has 2. It has 2 into 2. So yes. What about 3 and 6? It has 3. It has 2 into 3. So they have common factor. What about 24 and 50? It has 2 in it. It has 2 in it. Right? So they are not co-primes. Understood? Co-prime means which does not share any common factor other than 1. So that's how we start. We take A and B can be represented, and B is not equals to 0. Okay? In that case, it will not be defined. So what is the next step? You just cross multiply B here. Now just watch the steps. So it's B root 2 equals to A. Okay. Now what I'll do? Squaring both sides. So it is B square into 2 equals to a square. So b square equals to a square by 2 now. Alright. So here comes a theorem in your NCERT. If a square is divisible by any prime number, then a will also be divisible by the same prime number. So here a square is divisible by 2, hence a will also be 2. A square is divisible by 2, so a is also divisible by 2. Okay, if a square is divisible by 2, a is also divisible by 2. How I will use this? I will take 2 as the factor of a. If a is divisible by 2, if any number is divisible by 2, of course 2 is the factor of that number, so I can represent a as 2c. Okay, now better understand this. How did I write this? A equals to 2c. It depends on a, what c will be. If a is 6, it would be 2 into 3. If a is 12, it would be 2 into 6. If a is 8, it's 2 into 4. Like this. C depends on a, right? So it could be anything, but it will have 2 as a factor. Now what? The same method I will apply, squaring both sides. What I will get? A square equals to 4c square. Now that will be our equation number 1. Now what I will do is, I will substitute the value of a square from equation number 1 here. So from equation 1 here, 2b square equals to 4c square. Alright, so 4 will be in division, so 2b square upon 4, so 2 1 is 2, 2 2 is 4 equals to c square. Now what we got? We got b square by 2 equals to c square. Now again the same theorem. Here what we had written, a square is divisible by 2, so a is also divisible by 2. Here also the same. What? B square is divisible by 2, so B is also divisible by 2. B is also divisible by 2. B is also divisible by 2. In that case, A is also divisible by 2 and B is also divisible by 2. So A and B share 2 as a common factor. Now A and B both are divisible by 2. It means they are sharing 2 as a common factor. But what we have considered in the beginning, that A and B are co-primes. They doesn't share any factor, but they are having 2 as a common factor. It means what? It means our assumption was false, because this statement contradicts our fact that A and B are co-primes. That A and B are co-primes. It means, so our assumption is false. What assumption? What was our assumption? That root 2 is a rational number. Hence, root 2 is an irrational number, right? That's how you can prove. You can prove any irrational number irrational. Alright, that will be applied to root 2, root 5, root 3, alright, to root 3. So practice it and let me know your doubts. Now let's talk about the decimal expansions of rational number. In rational number, you have studied two kinds of decimal expansions in previous classes. In actually, you have studied three kinds of decimal expansion in previous classes. First, terminating. Second, non-terminating. Third, non-terminating. Okay, they both are non-terminating. What's the difference is? It is recurring or repeating, but this one is non-recurring. Okay, terminating, non-terminating, recurring, non-terminating, non-recurring. Okay. These two belongs to rational number, and this one belongs to irrational number. Alright, rational number which can be represented in the form of P upon Q. So all these numbers are rational number, okay, because they are written in the form of P upon Q. So of course they may have only two kinds of decimal expansion, terminating or non-terminating, recurring. They cannot have this because it belongs to rational and they all are rational. So now we are going to study how to identify by just checking the denominator of any rational number that it will have, whether it will have terminating decimal expansion or non-terminating recurring decimal expansion. Which one will they have? Okay, we will find out by checking the denominator of the rational numbers. How it works? Let me show you. If the denominator is of the form 2 to the power m into 5 to the power n, okay, if the denominator is in that form, then it will have terminating decimal expansion. It will have terminating decimal expansion. If it is not in the form of 2 to the power m into 5 to the power n, then it will have non-terminating recurring decimal expansion. Now, how to exactly find out this form, whether the denominator is of this format or not? Let me tell you. If there is only 2 to the power 2, if the denominator is of the form 2 to the power 2 means 2 into 2 like 2 to the power 2. It is of this form. Yes, because I can write it as 5 to the power 0. Right? It is of this form. If it is only 5 to the power 3, it is of this form. I can write 2 to the power 0 into 5 to the power 3. Okay. If it is 2 to the power 2 into 5 to the power 5, perfectly fine. M and n could be different. M and n are what? Non-negative integers. Okay. So it could be different also, but doesn't matter. It must have 2 and 5, or only 2 or only 5. But if it is of the form 2 to the power 2 into 5 to the power 5 into 3, any third number is also present there, then in that case it will have non-terminating repeating decimal expansion. Alright, and if it do not have 2 and 5, only have another digit, then in that case also it will have non-terminating repeating decimal expansion. Alright, let's check all this. First one, 13 upon 3125. What is the decimal expansion of 3125? 3125 equals to, it is 5 into 5 into 5 into 5 into 5. 5 to the power 5. Is it of the form 2 to the power n into 5 to the power n? Yes, it is. I can write it as 2 to the power 0 into 5 to the power 5. So it is terminating. Okay. Now next is 17 by 8. So 8 is of the form 2 to the power 3. I can write it as 2 to the power 3 into 5 to the power 0. It is not necessary that you write in that format. No, you just understand whether it is of that format or not. If you understood from here itself, then it is fine. No need to write this. Okay. So yes. So it is also terminating. Okay. Now next is 64 by 455. Alright, let's see. 455. What are its factors? 455 will be divided by, first of all, 5, then I guess 7 and 13. Right? For you, I'll do the prime factorization. 5, 91, 7, okay, and 30. Right, 5, 7, 30. So yes, it has 5, 7, 30 as its prime factors. So there is 5, okay, but there are 7 and 13 also. So it will not be considered as terminating decimal expansion. It will have non-terminating recurring. Okay, let's move to the next. (29 by 343). Okay, we all know 343 is the cube of 7, right? So it will have non-terminating recurring. Okay, now next is 15 by 1600. What is it? 1600 equals to 2 into 2, 16 into 2 into 2 into 5 into 5. So that is 2 to the power 1, 2, 3, 4, 5, 6 into 5 to the power 2. Correct? So it is terminating. Alright. Next is 6 by 15. What 15's decimal expansion is 3 into 5. So basically it should not be terminating, it should be non-terminating repeating, but there is a fact. What? If I write 2 into 3 upon 3 into 15, that 3 got cancelled. So it is actually 2 by 5. And now the denominator is of the form 5. So it would be terminating. Okay. Check if there also it happens, then in that case it may change, but it's not happening any one of these first 5 numbers. Okay, it's happening only the last one. Alright, that's how you can find out whether the rational number will have terminating decimal expansion or non-terminating recurring decimal expansion by checking its denominator, whether it is of the form 2 to the power m or into 5 to the power n. Okay, if it is terminating, if it is not, then it is non-terminating. After that, you must be knowing how to represent those who are having terminating decimal expansion, how to find out their decimal expansion, like 17 by 8. Which kind of decimal expansion does it have? Terminating, as we just saw, it is 2 cube. So how to find out its decimal expansion? You just need to divide 17 by 8. If you have been asked to find out the decimal expansion, so you have to divide it. 8 to the 16, 1.0. Okay. Now 8 1 ja 8, 2, 0, 8 2 ja 16, 4, 0, 8 5 ja 40. Done, it's terminated. 2.125. Right? That's how you can write the decimal expansion of all of them. Okay? So that's it in real numbers. Hope you understood everything. Solve the problems, solve the exercise, solve further books. You will get more problems like this. Okay? And let me know your doubts in comments. Thank you.